If you want to learn what makes a volcano erupt, you need to go right to the otherworldly source. Crunchy, oozing, red-hot source. At least that's what geologist Mike Garcia does. Voila! Wow. That's amazing. Amazing indeed. Welcome to the most studied volcano in the world, Kilauea. Garcia and I came to this surreal landscape on Hawaii's Big Island by helicopter. On our way, we got a glimpse of the red rock cauldron of magma through the sulfur-tainted sea. Kilauea is one of the longest currently erupting volcanoes on the planet. The lava started flowing in January of 1983.
So the mantle is producing an enormous amount of hot material that's coming out of Kilauea. This is probably one of the most active periods of the historical record of Kilauea.
The eruption waxes and wanes, at times spewing fountains of lava, and in the 1990s threatening and destroying nearby homes. Through it all, there is one constant besides the flowing lava: Garcia. He's been studying Kilauea for 30 years, thanks to support from the National Science Foundation.
Well, with most volcanoes, you want to know when it's going to erupt. And so that's the primary concern. But in this case, where we have an eruption that's been going on for 30 years, the big question is,
he comes here looking for data. In this case, a piece of freshly cooked earth, just out of the oven. He dumps it in water, freezing the moment and its chemical composition in time. A geological Instagram packed with data.
We know its birthday. We know when it was erupting. And you might ask, well, why do we care? Because the lava's composition changes hourly, daily, or even monthly. And somewhere there might be some sort of telltale sign of whether it's going to continue erupting or not, right? Absolutely. In science, one of the key things we do now are time series studies, where we collect samples repeatedly during the course of an eruption or in the ocean, because it's evolving all the time.
each of these processes within the volcano leaves a fingerprint. So over the years, we've been able to develop an understanding of what those fingerprints are and what they tell us about what's going on in the volcano.
So where we are now, we're
Looking at the rock collection we have, Kilauea eruption, as well as some of the other Hawaiian eruptions.
and over the years, he has amassed an impressive collection of rocks. Not just from Kilauea, but from volcanoes all over the Hawaiian Islands.
So this is July 23rd of 1997. And this one looks a little grayer.
It's not quite shiny for whatever reason.
But
Why
you
would
can
that
see
be?
the imprint. Well, it was a little cooler at the time it was wet.
I see. If only these rocks could talk. Fortunately, Garcia is pretty adept at reading them. One of the things he focuses on is the temperature of the lava.
So what we've seen is a long-term decrease. Initially, the lava temperature was low. It increased, the eruption roared upward, and now it's been slowly waning and we see the temperature of the lava is indicating decrease. So we think this eruption might end in the near future, but it's ended several times in the past. It was quiet in 1997 for a month. Then we started.
At the lava flow, Garcia told me his work is not as dangerous as it seems. A calculated risk for a good scientific cause.
So what is the strategy for walking? How do you know what to step on? We need to avoid areas that look shelly, indicating that the lava is drained out from underneath. So we try to look for places where it looks solid, so we can avoid collapsing in on the lava flow.
I'm just going to follow you. How's that?
Very good.
But while we were here, newly minted, still hot Hawaiian earth melted the soul right off his shoes.
Wow, just like that.
No. Oh, you're absolutely right.
Holy moly! Wow. All in a day's work for an intrepid geologist determined to go with and to the flow.
Just like that.